The operators are in between the operands are called infix expression. Only one element 11 was there. So we have to pop out this. So we are left with the stack as empty. There are no elements. So it is empty stack and the result is 11. So we have to pop the elements from stack till it's encountered and append the popped element in postfix or post expression. Dear students, welcome to Computer Science classes. I am Ravi Kumar Kyar, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start up a discussion with the chapter stack. So in this session, we are going to cover the topic about arithmetic expression and types of arithmetic expression, infix, prefix and postfix, and evaluation of arithmetic expression. Let us start with what is arithmetic expression. So in our previous session, we have learned about the basic definition of stack and different operations on stack, push and pop operations, and also we have learned how do we represent through Python programming statement. So in this session, we will continue our discussion with one more concept, that is arithmetic expression. So you know what is arithmetic expression in programming concept? Arithmetic expression, it is a combination of operators and operands. Now you know what is operators and operands. You have learned in your previous basic of Python programming. So if you look at this expression, a plus b plus c, here plus is an operator, plus is an operator, and on either side of operator is called operands. So here on either side of operators are called operands, and this is plus is arithmetic operation. So arithmetic expression is a combination of operators and operands. This is an example for arithmetic expression. Now look at one more example here. So here we are using x plus y within the bracket and here star, again within the bracket x star y. So star is as the asterisk multiplication operator. So this is plus is additional operator. So this is an example for arithmetic expression. So any expression, arithmetic expression can be represented in any of the three notations. One is infix, prefix and postfix. So any of these expressions we can represent in three forms or three methods or three notations. They are infix, prefix and postfix. These are the three types of notations we can represent any arithmetic expression. Now let us see what are the three types and the definition with examples. So here first we have infix expression, prefix, another name is called polishing, and postfix, it is reverse polishing. So what is infix here? The definition of infix is an operators are placed in between the operands. Now we know what are operands and what is an operator. So on either side of operators or operands. So here the operators are in between the operands are called infix expression. Now look at the example here. If you look at this example here, see here x plus y star z star y. If you observe this here the plus is an operator. See, this is infix between the two operators. And here again this z star phi, star is an operator. Here we have two variables or expressions. So this is expression. So this is an example for infix where the operator is in between the operands. That is infix. Now let us see what is prefix expression. So here the operators are placed before the corresponding operand. So observe this. This is operators are placed before the operands. So that is prefix. Prefix is nothing but the operators are placed before the operands. Now look at the example here. If you observe this here, plus z. Here z is an operand and plus we have placed before that. So this is, and again if you observe one more star, it is before x, y. So in that way, this is an example for prefix notation or prefix representation of arithmetic expression where the operators are before the operands. Same thing here, you can observe this here, star 3 means 3 is an operand, star or asterisk is an operator. Again it is before 3, and here 4, 5, and before that we have plus operator. It is before the operands, it is a prefix expression or prefix notation. Next one is we have postfix or reverse polish. What are postfix definition? The operators are placed after the corresponding operands. So here in prefix before the corresponding operands, in postfix it is after the corresponding operands. Now look at the example here. Now here xy star, here the operator star is after this operands xy. Similarly, here is plus, this is the plus operator, it is after z, and that is 3, 4. So here look at one more example here. Here 5 plus star and xy plus. See, these are the operators are after the corresponding operands. So here again z5 star, and that is division, that is oblique, there is a forward slash, that is division operator. So if you observe all the three, so these are all different methods of representing arithmetic expression. They are either infix, here the definition is the operator is between the operands, prefix means the operator is before the operand, and postfix means the operator is after the operands. These are the three types of expressions. In the next slide we will see evaluation of postfix expression. Now next one of the application of stack is, that is evaluation of arithmetic expression. So here the stack is commonly used data structure to convert an infix expression into equal prefix or postfix notation. So this is one of the application of stack data structure. So here it is conversion of infix expression into either prefix or postfix. And what is the algorithm, what is the procedure here? See, by a conversion of an infix notation, prefix or postfix notation, only operators are pushed onto the stack. Please, this is one of the logic or algorithm. Only we are pushing the operators, not the operands, into the stack. This is the one point in algorithm. Now let us see an example here. Let us see how do we convert given infix into postfix notation. So this is evaluation of arithmetic expression. This is an example for convert the given expression. See, this is the given expression, x plus y within the bracket slash z star 8 into postfix expression using stack is a data structure. Now let us start with the procedure in algorithm first. See, first you know that initial stage stack is empty. So please observe this. This is the given notation or expression. So at the beginning the stack is empty. Next one is, if you observe the expression, now the first here, as we have seen in the previous slide, we have to push the operator into the stacks, not the operand. Now from reading from left to right, we have come across first one is bracket here, left bracket, that is we have to push into the stack. See, first it was empty, now we are pushing stack one operator, this is a slash, this is the small bracket, we are pushing into that. Next we are moving to x operator here, x comes here, we are not pushing into the stack as per the algorithm. X will be, we are writing as it is here. Next after x we have plus operator here. So operator we have to push to the stack. After this we are pushing here. Because this is, you know that insertion takes place at the same point at the top pointer. So this after this next position is this, we are pushing this. Next one we have to read y. Y is the operand. So y comes here. After pushing this we are left with y. So xy. X plus y, and here is xy. Y is an append to the string on postfix. Next slide, we will continue with the example. Next, after this, we have small bracket closing. Now, if you observe the question here is a given expression. We are working on this now. See, that is bracket here, small bracket. So we have to pop the elements from stack till it's encountered and append the popped element in postfix or post expression. See, whenever this comes here, this is a closing of the small bracket, then we have to pop all the elements till we reach the one operator, and we have to append the popped element in the postfix. So accordingly, xy plus, if you look at the previous slide, see in this one xy and here is this. So we are pushing this one to this location. So that is as per this algorithm. Accordingly, this is the statement after popping out the elements. I mean, once we have come across this operator, we are popping the elements till we reach the operator. Next one is, if you look at the example, next we have come across this, that is division operator. So division operator, so we have to push this to the stack. Then after we have again small bracket here. Now we have to push this small bracket into the stack. So this is one. Next again we have apparent z. If you look at the question here, we have z star 8 and closing this. So z, we have to append z to the string here outside the stack. So here it was x plus y, now it is z here, x plus y plus z. After z, we have star operator. So operator we have to push to the stack. So string will be xy plus z as it is. It was in the previous step. Now again after this, we have come across, this is the operand value 8. We have to append to the string outside the stack. Here it was z. Now 8 is an operand. We are append to the string outside the stack. So it is xy plus z8. Then after this operator, as we have done this, what we have done in the previous step, repeat the same thing here. Once we have come across this type of this closing bracket, we have to pop the element till we get the operator. So accordingly, the previous operator was star. We are pushing this here. So we are pushing this here and we are left with only one operator in the stack. So next one is, again we have to end of the expression, pop all the append to postfix. This is the end of the expression. We have to pop all the operators and we have to append to the post expression, means here. So it was the only element, it was the only operator inside the stack. So this has to be eliminated and this one appended at the end of this. So here xy plus z8 star, and after this, at this point, we are going to add this. So this is the end of the expression. So once if you observe this, this is the final stack, and here there are no more operators here. This is the post expression, means after removing all the elements or all the operators from the stack, we have left with the final string. This is the string that is post expression. So the given expression was x plus y within the bracket by z star 8. This was the expression given. So this is infix expression. So at the end of the final stage, see, we have reached the stage where the given expression has converted into postfix notation. So this is xy plus z8 star plus, this is the final expression after evaluation of arithmetic given expression using stack. Here observe this, here xy plus, this operator is after the operand, that is postfix notation. Again star is after z8. Finally, this is division operator. It comes at the last, at the end. So this is the final stage we have reached while converting the given infix expression into postfix expression. So this is one of the applications of stack. Now in the next slide, we will see one more application of stack, that is conversion from postfix expression or evaluation of postfix expression. Now we observe that this is a postfix expression because the operator is after the operand. Even operate here, the operand 4 is operand, then we have operators. Now let us see how do we solve it or how can we do evaluate with the help of stack. So at the beginning, stack is empty, and here the first value operand is 7. So in this example, we are pushing the operands, not the operator. As we have done in the previous example, we used to push only the operators. Now in this example, we are pushing the operands into the stack here. The first operand is 7, we are pushing into the stack 7. Next operand is 8, we are pushing 8 here, it go to next place or next index. Next one is after 8 we have 2, so we are pushing the operand 2 into the stack. Now there are 3 elements here, 7, 8, 2. Next step is, after this, we'll get this star is an operator. Once we get the star operator, so the algorithm is pop 2 elements, apply the operator and push back the result. So this is the algorithm or the procedure. Once if we get the operator, have to pop 2 elements. We have to pop 2 elements from the stack and we have to apply operator. Suppose if it's star operator, we have to multiply the 2 operand. If it is plus, we have to add the element. If it is minus, subtract one from the another. Or if it division, we have to divide one from the another. Accordingly, after then the result will be pushed back to the stack. So accordingly, once if we get the star here, so we have to remove 2 elements. If you look at the previous slide, these are the 2 elements, we have to remove it. 2 and 8 has to be removed. So then after removing 2 elements, apply the operator, the star, 8 into 2, that is 16, and push the result to the stack. So here we got a 16 because we have removed 2 elements, 2 and 8, and we are applying the operator multiplication. 2 into 8 is 16. The result is we are pushing into the stack. So here 16 is the one element, this is the 7 is the first element. Now in the next step, we will see next one is 4 is operand, we have to push into the stack. So the elements are 7, 16, 4. Then again next one is we have division symbol, that is /. So again same rules we have to apply, pop 2 elements, apply the operator, push back the result. So here in this example we have to pop out the 2 elements, 4 and 16, it has to be popped out of the stack and apply the operator, division operator. Now we have to divide 16 by 4. 16 by 4, quotient is 4. So the result we are pushing into the stack. So here 16 divided by 4, quotient is 4. So the 4 is we are pushing the result into the stack. Now these are the elements in a stack, that is 4. Next one here is 7. In the next step we have plus operator. So once the plus operators comes here, again we have to pop 2 elements, apply the operator, push back the result. In the previous step, these are the 2 elements, we have to pop out these 2 elements, 4 and 7, and accordingly 4 and 7 you have to pop up, apply the operation, plus operation. So here 7 plus 4 is to 11, so we have to push the result, 11 we have to push into the stack. Now we are left with only one element in the stack. Next one is at the end of expression, we have to pop out all the elements from the stack. So here the only one element 11 was there. So we have to pop out this. So we are left with the stack as empty. There are no elements. So it is empty stack and the result is 11. So this is the evaluation of the given postfix expression with the help of stack operation. So this is another applications of stack. Students, so far in this session, we have learned the different types of arithmetic expression and how do we represent arithmetic expression in different forms, and also evaluation of given arithmetic expression into other forms. We will continue our discussion in my next session. Thank you very much.